In today's lecture, we are going to discuss all the possible numericals that can come from displacement current. Before doing that, let us quickly see the symbols and the formulas which we are going to use. Epsilon naught is permittivity of free space. Its mathematical value is 8.85 into 10 to the power of minus 12. Mu naught is permeability of free space. Mathematical value 4 pi into 10 to the power of minus 7. Flux for electric field is E dot A, for magnetic field is B dot A. Gauss law is the total flux passing through a surface is equal to the total charge divided by epsilon naught. Stokes law, integral F dot dr is equal to integral S del cross F ds. Charge is current into time, current density is current upon area. You can also write current in various forms. Continuity equation, divergence J is equal to plus del rho by del T is equal to 0. Gauss law in electrostatics, del dot D equal to rho, where your rho is your charge density and D is the displacement vector. Okay, now let us quickly see the numericals that can come. One more thing. Displacement current density is given by del D upon del T, and the total current density J is equal to conduction current density plus displacement current density, and they both are equal. Displacement current ID is equal to epsilon naught d phi E by dt. That is, displacement current arises because of the change in electric flux. The surface area of a sphere is dA is equal to r square sine theta d phi. Numericals. Find the total current in the circular conductor of radius 4 millimeter if the current density varies as this much. So I know the formula I is equal to integral J dot ds. This is current I and J is current density. J has been given as 10 to the power of 4 by R. And this millimeter I will have to change into meter. So it will become 0.004 meter. And then integration will be, because it is a circle, so pi will vary from 0 to 2 pi, and the radius will vary from 0 to 4 millimeter. That is 0.004 meter. And then I will simply put these values and get the answer. The vector current density you have been given in this form. Now you have to find the total current and J. Now see, R at 3, theta equal to 0, theta equal to pi. So it is very simple. You know, cos 0 is 1, sine 0 is 0. And again here a sine theta is coming. That is also 0. So very simple. Your equation itself will reduce to the very first term, J equal to, and R is 3. So this much upon this. Total current I is integral J dot ds. So ds is surface area of a sphere, which is given by r square sine theta d phi. So you put this value here, multiply, limits have been given to you, r equal to 3, theta is 0 to 20 degree, phi is 0 to 2 pi. And when you get phi equal to 0 to 2 pi, theta equal to 0 to 20 degree, other terms here are simply going to become 0, because theta dot r is equal to phi dot r is equal to 0. And then we take the limits. Another formula, when we are seeing cos theta, sine theta, we can use the very famous maths formula, sine 2 theta is 2 theta, sine theta, cos theta. To make this term equivalent to this, you multiply and divide by 2. So now your equation comes in terms of sine 2 theta. An integral of sine theta is cos theta. So 0 to 2 pi is the limit. Straight away put the values and you get your answer. Is the same as conduction current. Next question. For a conducting media, you have been given the conductivity and epsilon r. Find out the conduction and displacement current densities if the magnitude of electric field E has been given to you like this. See, conduction current density is sigma E. This we know from the formula. Sigma has been given to us. E has been given to us. Just straight away put the values. Displacement current density JD is equal to del D by del T. And epsilon is equal to epsilon naught into epsilon R. Epsilon R is equal to 1. It has been given. See the numerical. Relative permeability has been given to you as 1 here. Epsilon r has given to be as 1. So I will put the values, and epsilon naught is 8.85 into 10 to the power of minus 12. And simply put the values and you get your answer by simple calculation. For harmonically time varying fields, D is equal to D naught e to the power of I omega t. So this we are doing so that we can get a formula for F. Omega is angular frequency at which conduction current is equal, density is equal to displacement current density. So sigma E is equal to omega epsilon E. And straight away, E and E will get cancelled. Omega is sigma upon epsilon. Omega is 2 pi F, which is equal to sigma upon epsilon. So frequency is sigma upon 2 pi epsilon. And instead of epsilon, we will put epsilon naught into epsilon r. Straight away, put these values which you have been given in the numerical and you get your answer. In a material for which this is this, find the conduction and frequency at which both have equal amplitude. It is the very same question, just a minor difference that now they have asked this. Now in a cylindrical conductor of radius 3 mm, the current density varies with distance from the axis as itna. Find the total current. Integral J dot ds. ds is d rho d phi. Rho is 3 mm. You change it into meters, and angle will be between 0 to 2 pi, how we have done in the previous numericals. Now, integral 0 to 2 pi d phi is 2 pi, and let t be minus 400 rho. Put this as t. So your limit when rho is 0.003 will become 400 into 0.003 is equal to t. So t is equal to minus 1.2. E to the power of 0 is equal to 1. Straight away put these values and you get the answer. Find the current density. Find the current density. Next question. In spherical coordinates for conical strip theta equal to pi by 4. Again, I is equal to j dot ds. ds is for the sphere case in spherical coordinates. So for the case of sphere, and this j has been given to us, multiply, you get it sine theta cos theta r. We have done it in one question above again. Repeat, you have been given the limit of r as 0.001 and 0.080. And phi is 0 to 2 pi. And here theta is pi by 4. So this you get the answer. Now you have to change log base e to log base 10. So log base e when changed to log base 10 becomes 2.303 log base 10x. So this we change and we put the values, take the limits, and we get the answer. Thank you.